Hello students, how are you? Welcome to Sri E Physics class. In earlier classes, we have seen uniform motion and non-uniform motion. Today, we are going to see the average speed and the acceleration and their formulas and also numerical problems. All of you please follow the notes. See the average speed we are talking about. Why this average speed? You see here, whenever we are talking about uniform motion and non-uniform motion, we said that an uniform motion means it covers equal distances in equal intervals of the time. But non-uniform motion means unequal distances in equal intervals of the time. Just I'd like to explain about the non-uniform motion first with simple line so that you can understand it. For example, this is a road or a path, let us say. Here we are talking about equal time. First 0 second, 1 second. Suppose speed increased in 2 seconds, it will go more distance. Speed is decreased a lot, 2 seconds it will, next second it will cover less distance. Speed increased much more, then it will cover large distance. Like that, what happens, even though the time is the same, distance covered will be different depending on the speed. What I mean to say here is that more the speed, more the distance is covered. Less the speed, less distance it cover. Like that, it covers unequal distances. You see the unequal distances, but equal intervals of the time. 2 seconds, 3 seconds, 4 seconds, like that. In daily life, most of the cases are non-uniform motion only. Non-uniform motion. Most of the cases. Here, whenever non-uniform motion is there, we talk about average speed. Why? I'll tell you. For example, you are traveling in a city bus. Let us say that first, whenever you are getting into the bus, it is 0 kilometer per hour. After some time, it picks up the speed, goes to 10 kilometer per hour. Then after 20 kilometer per hour. Then after, if the traffic is not there, it continues to 60 kilometer per hour and continuous like that 60 kilometer per hour. Then if there is a traffic, then it will come down to 20 kilometer per hour, like that. So every time there is a chance that speed may increase or decrease. Depending on the speed, distance covered will be varying, will be different. That is called a non-uniform motion. In this case, as the speed is different for different timings, what we do is that for the total journey, we define average speed and we calculate the average speed. Let us see the definition of the average speed first. So I am giving the definition of the average speed. Average speed, just you see this definition, we'll see here. It is defined as the ratio of total distance covered to the total time taken. Observe carefully here, the keywords are that total distance covered and total time taken. It is the ratio also. Ratio means you know very well, one will come in the numerator and other will come in the denominator. I'll give you the formula for this average speed. Average speed is equal to ratio means in the numerator, as I said here, total distance will come. Total distance will come. Whereas in the denominator, total time will come. This is the formula for that one. As usual, the unit of this one is also same. SI unit is average speed also. It is meter per second SI unit. As usual, other units also we can say that kilometer per hour, miles per second and all those things. It is very similar to normal speed only. So average speed. Only one point I'd like to stress and I'd like to tell you that this average speed, which we are talking about, average speed, we use it when a body is not moving with uniform speed. In daily life situation, most of the cases, bodies will not be moving with uniform speed. Therefore, different speeds it will be moving. Therefore, we'll take up the average speed. For example, I'll give one example. You see that example, you will understand it. Simple example, I'll take it up. Average speed. Let us consider a car travels first 15 kilometer in, let us say that a meter, I'll take it up here, kilometer, because SI unit I'd like to take up first. 15 meter in 10 seconds. And 25 meter in 20 seconds. You see, first it is 15 meter 10 seconds, then after 20 meter in 20 seconds. The first part, distance is different, time is different. Here distance and times are different. Two parts are there here. Object travels first part 15 meter in 10 seconds, second part 25 meter in 20 seconds. See, average speed we have to calculate. Calculate average speed. To calculate the average speed, what we know that this is the formula we know very well. Total distance we have to calculate first, then after total time we have to calculate it. Okay. Now, so first what we do is that total distance we will take up now. Total distance means these two parts we will calculate it. 15 meter plus 25 meter, that is 40 meter. Total time taken. Total time taken is 10 seconds plus 20 seconds, that is 30 seconds. Now, here total distance is this much, total time is this much. You have got 40 meter and 30 second. Average speed, we will write the formula, which is equal to total distance by total time. See here, total distance is 40 meter by total time taken is 30 second. Now, 0 0 gets cancelled. It is 4 by 3 meter per second average speed. If you want, you can convert into decimal also. That is equal to 3 ones are 3, 1 again 3 meter per second. That is 1.33 meter per second. Just to see, once again I will explain. An object travels first 15 meter in 10 seconds and next 25 meter in 20 seconds. Two parts. Calculate the average speed. Easy one I have taken first. What you have to do to calculate the average speed? Total distance is to be taken. Total time is to be taken first. Total distance, let us calculate first. First part distance 15 meter. Second part distance is 25 meter. Total is 40 meter. Total time taken is first part 10 seconds, second part 20 seconds. Total is 30 seconds. I mean to say we have got total distance 40 meter, total time 30 seconds. You know the formula. It is better you to write the formula again in the problem whenever you are solving the problems in the examination also. Average speed is equal to total distance by total time taken. Total distance is 40 meter by total time 30 seconds. 0 gets cancelled. It will become 4 by 3 meter per second. Why meter per second we are getting? Here taking meter and here you are taking second. Therefore meter per second. That is equal to 1.33 meter per second you have got. This is the average speed, we can say. Okay, observe carefully this question. I'll take up the one more problem after this. All of you please go through this, try to understand. Then after I'll explain the another problem. Dear students, for your reference, I have written the problem and ready. I kept ready here for you. Just to go through this. I to read. Usha swims in 90-meter long swimming pool. She covers 180 meter in 1 minute. How much time she is covering? In 1 minute she is covering. So this is the time is 1 minute. By swimming from one end to the other, starting from the one end to the other, and also back, along the same straight path, find the average speed. Let me draw with a simple diagram, you will understand it. This is a starting point, this is the end point, and from here again come back here. Now let us see here, from here to here, it is 90 meter. Back again 90 meter. So if she covers like this and coming back, it will become 180 meter. That only they have given. Now you can easily imagine and tell me what is the total distance covered from one end to the other and back. One end to the other and back, 90 plus 90 is total distance covered. Now, how much time they have taken? Usha has taken. It is mentioned in the problem that 1 minute. It is a time 1 minute, not second. You have to remember 1 minute. So to go from A, B and coming back to C, 1 minute time taken means that total time taken is 1 minute. So from this question, first we have to write total distance. Total distance. Total distance is equal to 19 plus 90. Already they have given it as a 180 meter. You write it as a 180 meter. Then after total time taken. Total time taken is 1 minute. You have to remember that minute is not a SI unit. You have to convert into second. You know very well 1 minute contains a 60 second. Therefore, we will write it as a 60 second here itself. You have to convert here only before substitution only. Now you write the formula. Average speed is total distance by total time taken. Total distance is 180 meter by total time taken is 60 second. Now if you see, you will find out that cancellation possibility is there. 0 gets cancelled, 6 ones are 6 threes are. So finally what is coming here? 3 meter per second. This is what is called average speed. Okay. Now I think you have understood this. Average speed means always you see the formula total distance by total time taken. in any problem you have to find out the total distance from the given data and also total time taken. Then you substitute, you will get it the answer after substituting the values. In this problem, average speed is equal to 3 meter per second. Now, I'd like to go to another concept, average velocity. You can easily imagine the definition of average velocity. I am explaining this average velocity. All of you see this. The average velocity means it is defined as the ratio of net displacement to the total time taken. Formula is, I am talking about average velocity now. Average velocity is equal to, you have to write net displacement by total time taken. Observe carefully this difference between these two formulae. Average speed, in the numerator we are having total distance, whereas for the average velocity we are having in the numerator net displacement. That is the difference. So whenever we talk about net displacement, then we say that average velocity will come. Whenever you say total distance, speed will come. I mean to say it is a scalar quantity, therefore we will get here scalar quantity. Here it is a vector quantity, therefore we will get it a vector quantity here. I'll explain a problem to you. Just you see, try to understand that problem. By the meantime, learn the definition and formula. I'll come to you now with a simple diagram. Dear students, I'd like to give one small numerical to you. Just you go through this given thing and diagram also I'll explain. It is a numerical example to understand average speed and also average velocity. Let us see what is the problem here. Example, truly speaking, a body starts from A, means it is starting from A, and reaches D. How it is reaching? It is going like this. See the arrow mark, going like this, going like this, going like this. Means it is going A to B, then B to C, then C to D. Remember, it is not going directly from A to D. That is what they want to say in this problem. Through BC it is going. Okay. In how much time it is going? In 5 seconds it is going. Means object is covering A to B, B to C, C to D in 5 seconds. Calculate the average speed and also average velocity. So just now we have seen that to calculate the average speed we require total distance, whereas to calculate the average velocity we require total displacement, that is net displacement. First I'll go to the average speed calculation. For that, as I said, we have to calculate total distance. Total distance is equal to, just you see here, it is AB plus BC plus CD, not DA, because it stopped at DA, reached D only. AB is how much? 6 plus 10 plus 6. 6 plus 10, 16 plus 6 is 22. Is it correct? Observe carefully. It is a rectangular path. 6 meter, 10 meter, 6 meter, 6. Total distance you have got it now. You calculate total time also, not calculate, total time given already. Total time how much it is given? It is 5 seconds it is given. Write it. Now compulsory it is better to write the formula always. That is average speed is equal to total distance by total time taken. What is the total distance you have got it now? 22 meter by 5 seconds. That is equal to divide this 22 by 5. You will get it 5 4s are 20. Again 4s are meter per second. Average speed it is. Now we have got the average speed. See, for the average speed, we calculate the total distance 6 meter plus 10 meter plus 6 meter. Remember, it has stopped there at D. Now we'll go to what is that average velocity calculation. For that, we have to find out the net displacement. See, I'd like to remind you, displacement is a vector quantity. According to the definition, displacement is defined as the shortest distance between initial point and final point in a particular direction. If the path is covered from A to B, B to C, C to D, this is the initial position, this is the final position. Now, object has not traveled along this AD, but displacement is in this direction. Displacement is in this. Displacement is in this direction. It is A to D. It is there. How much displacement is there now? That is 10 meter. Matlab, even though it has moved round like that, finally change of the position from A to D is 10 meter. I think you have understood. So net displacement, I am covering it as a 10 meter. What is the total time taken? Total time is as same thing. Total time, because for the same thing we are calculating. So it is 5 seconds. Again you write the formula. Now it is the average velocity we are calculating. For average velocity, write net displacement by time taken. Net displacement we have got 10 meter by 5 seconds. You know very well 10 divided by 5 is equal to 2 meter per second. Observe carefully. This is a average speed. This is a average velocity. Whenever you are calculating the average velocity, you have to compulsorily mention the direction. The direction is from A to D. You have seen direction of the displacement is A to D. Remember, object has not moved along this A to D. It has moved like this only really. But displacement initial position is here, final position is here. Shortest distance of initial to final position is along this direction A to D. Therefore, net displacement we call it as A to D, and therefore average velocity direction is also A to D. This is one of the examples to compare the total distance and total net displacement at the say and also average speed and average velocity. Okay, I'll go to the next topic now. Pause. Acceleration, it is defined as rate of change of velocity. What is meant by velocity? You know very well, it is a speed plus a direction. Means speed along with the direction we call it as a velocity. Therefore, by the definition of the acceleration, we can write the formula. Acceleration is equal to final velocity minus initial velocity by time taken. Final velocity is indicated by V, initial velocity is indicated by U. So U is equal to V minus U by T. This is what the acceleration. Acceleration means the velocity in the beginning and velocity at the end, and how much time it is taken to increase the velocity from initial to final. That is what this one. And the acceleration symbol is A, final velocity symbol is V, initial velocity symbol is U. SI unit of this one is very simple. You see how to get the SI unit. Velocity SI unit is meter per second. Velocity unit numerator I wrote it. Time unit is S divided by 1. Therefore meter per second, and this second it is in the denominator. If you write it, it will become 1 by second. Therefore meter per second square you will get it. I can say that now SI unit of acceleration is meter per second square. Meter per second square, this is the SI unit. It is also written like this, meter second minus 2. You know very well in mathematics 1 by x square is equal to x to the power of minus 2. It is a most important question. Listen carefully. I will give a numerical problem to you. Dear students, I have written one numerical problem. Just you see this. An object starts from velocity 10 meter per second. Starts means it is the initial velocity. And increase it to its velocity to 25 meter per second. That is, it is a final velocity. In 3 seconds means total time taken is 3. Let us write all these things given first. Given initial velocity, I think easily you have seen that we write it like this. Initial velocity u is equal to, indicated by u, already I told you that. U is equal to 10 meter per second. Final velocity v is equal to 25 meter per second. Okay. Time taken t is equal to, time taken t is equal to, you see here it is a 3 second. So what you have to find out here, you write it, acceleration a is how much, you write it like this, a is how much, that is to be find out. So what you do is that you write acceleration a is equal to v minus u by t, formula compulsory you have to write it. So v is 25 minus u is 10 by t. T is 3. Just you see that t is equal to 3. I would like to tell you once again, v 25 I have written, u 10 I have written, t 3 I have written. That is equal to 25 minus 10 is equal to how much? Now 15 by 3. So what is this? 15 meter per second by second, actually 3 second. That is going to be 15 by 3. It is going to be, you know very well, if you divide it, 3 5s are 15 meter per second square, not second, second square. Acceleration is equal to 5 meter per second square. Okay, this is for this problem. Once again, quickly see this. Initial velocity u is given 10 meter per second. We have written u is equal to 10 meter per second. Final velocity v is equal to 25 meter per second. We have written. Time is equal to 3 seconds. And then after acceleration formula we wrote v minus u by t. V and u we have taken from the given things, substituted 25 minus 10 by 3, then 15 by 3. Finally we are getting 5 meter per second square. Okay, I think all of you have gone through this and understood how to calculate the acceleration. In next class, we'll see some more problems. Dear students, I think you have followed today's lesson, and in this lesson, I have covered the average speed, average velocity, numerical problem based on that, acceleration definition, acceleration formula, and also one small numerical problem based on the acceleration. We are having only many more numerical problems. In the next class, I'll take up the numerical problems based on this. Okay, all of you go through this video, watch this video completely, and please give the feedback in the YouTube channel only. Any suggestions also you can give, no problem. But I request you to write your name, class, section. Then only I can understand whether you watch it or not, how many of you have watched, like attendance I can say. Okay, thank you very much for watching. Okay, all the best and have a nice day. Seriously watch the video and give the feedback. Thank you very much.